that gate, control how much material you have coming out, or you can just set that at a set height, and then the variable speed, you can adjust the RPMs of that belt to adjust the flow of aggregate going to the mix. In line in that wave, in that conveyor belt, is what we, a weighing system, what is referred to as a weigh bridge. This is the weigh bridge here. The belt's turning along with the aggregate. And keep in mind, this is wet aggregate. It sends back a signal to the asphalt plant in tons per hour. That says 325 tons per hour of wet aggregate. QC technicians are required a minimum of once daily to run a moisture test on the aggregate. And he will relay that information to the plant operator who enters that moisture content into the computer, and it will adjust. Say it had 5% moisture here in this aggregate, it would adjust this 325 tons down to what it would be at a dry tons per hour. I mentioned the wet aggregate comes in, it's being dried about 2/3 of the way down. The asphalt binder is sprayed in to the drum where the aggregate's coated, and then the hot mix will come out and go up to a silo. This particular plant here just shows you the inside of the drum. You have a series of lifters and flights that just keep that aggregate suspended inside the dryer so we can get rid of all the moisture. This particular plant has what's referred to as a coater box. Instead of the asphalt being sprayed directly into the drum, this coater box here, the asphalt is sprayed into it, the aggregate will go in there, and that's where the aggregate is coated. It's very important at a drum plant that you run that plant as continuously as possible. At the beginning of an operation and at the end of the operation every day, there's a lot of waste, anywhere from maybe 30 to 60 tons of waste at the end of the beginning and end of the day. So if you have to start and stop a lot during the day, if you do it like you're supposed to, you're going to have a lot of waste. I know some of the contractors don't do it like that. They'll just change on the fly and wind up with a gap in there of about 30 to 50 tons, something like that. A mix that probably does not meet specifications. Any questions? If you look on into your manual, let me get this thing. Look on in your manual. I think that the next thing that's listed in there are the additives that we talked about this morning. We talked about the two different types of additives. Silicone being one, that is put directly into your binder tank and mixed out there. The other one is your anti-strip additive. The contractor has two options with his anti-strip additive. He can either have it, he can either put it in at the plant site himself through an inline blending system. All he has to do is put in a heated tank, pour the anti-strip additive in, have the proper plumbing work there to get the anti-strip to the asphalt feed line, So there's got to be a series of baffles inside that feed line to make sure that that anti-strip gets mixed with the asphalt binder. If you read on down through there, we do require what's referred to as a totalizer flow meter. This is a meter that's opposite, and it's not opposite, but it's different than your metering system that pumps the anti-strip into the feed line. This is a meter that is in line just before it goes into your asphalt feed line that reads continuously. You cannot reset it. It comes from the factory set at 0, and it just keeps right on going. The plant technician or QC technician at plant site is required to read that meter several times a day, beginning production, during production, and end of production. And he is required to report those readings on the proper form. I think it's the QC1 form or something like that, and he has to report those numbers on it. Any questions on that? The next option the contractor has is he can have his supplier put the anti-strip additive in at the terminal. If he does that, again, it has to be inline blended. I believe if you read on down through there, it says that during the loading of that tanker, say you get a 6,000 gallon load, during the time that it takes that 6,000 gallons to get into that tank, that anti-strip additive has to be inline blended at least 80% of the time of the loading of that tank. And then all he has to do when it gets to the plant is just pump it directly to his asphalt feed line and you go to the dryer. Any questions on that? One other thing that's mentioned there in your manual is the Department of Agriculture and Consumer Services. They require that all scales that are used to sell off of be certified by the Department of Agriculture and Consumer Services. They come by every so often and put in a sticker. I would point out to you that you go down and read through that list of their requirements there. It says they will only themselves check platform scales. They will do that and put a certification sticker on them. And if you at a plant that's got load sales and stuff like that, you're required to hire a certified scale company to come out and do that test. But they will have a representative there to make sure it's been done correctly, and then he will put that sticker on the scale. And like I say, if it's used to sell off of it, that's not just asphalt. If you go to the grocery store and you buy a steak and he puts it up on the scale, what's on that scale? Department of Agriculture sticker. You go up here on the corner where it's $4 a gallon, what's on that pump? Weights and measures and stuff like that. And I hope like the devil they got it right. But they do certify anything that you sell on. Any questions on that? Section 5 of the set deals with asphalt plant equipment. We don't go into it in this class, but Section 6 of the manual goes into a lot more detail of the asphalt plant and equipment and operations and stuff. It goes into frequencies of checking, like your weigh bridges, asphalt meters, pumps, and scales and stuff like that. Actually goes into to computing hot bin weights. How much do I need to pull out of hot bin number 1? How much do I need to pull out of 2? What percent of each one of those materials do I need? We don't have time to go into that in this class. But if you're going on to be a level 1 technician, you'll be able to do it blindfolded. We cover it in great detail when you go to a level 1 class. Any questions or comments? If not, I will turn it over to Wayne.
Turn on to section 7 in your manual. As you see, section 7 is on plant mix sampling and testing. If you're a plant technician, this is probably by far the most important section in the manual. This is the section in the manual that contains all the requirements related to sampling and testing of the mix at the plant site. It has all the actual test procedures written into this section. Naturally, all of the frequencies of tests, all that type of stuff are covered. For our purposes in this class, we're going to sort of cover it. In general, we're not going to get into a lot of detail. We don't cover test procedures at all in this class. I'll sort of show you where they are in section 7, and we're just going to skip over them. Again, as I mentioned earlier, realize that there are a lot of tests required to be done on the asphalt, but some of them are done daily, weekly. The plant technician is not running all these tests every day by any means. We'll start out with the lab requirements, and then we'll go into some of the other general requirements as we flow over through the section. If you'll turn page 2, 7-2, we'll first talk a little bit about what the lab requirements are. The contractor, for most part, is required to furnish a certified lab at the plant site. You'll see in that first sentence there, it says the contractor 5,000 or more total tons, the contractors will furnish and maintain a certified laboratory at the plant site. That's wording that comes directly out of our specifications. It's read that way since day 1 of our QMS specs. Early on in the QMS process, it was thought that we might have some smaller contractors that the cost of setting up a lab would be so burdensome that they would not get involved in the process. So in order to allow them a chance to do work, it was written this way, that if you had a small contract, less than 5,000 tons, then a contractor can actually hire the testing work done by someone else and not have to have a lab at his plant site. Now realize that if that occurred, the technician still had to be certified. The lab, wherever it was located, still had to be certified. The same requirements applied. If the test had to be done in 24 hours, it still had to be done in 24 hours. It just gave him the option to do that. I would say that we did not see much of that. We thought we would, but we did not actually see very much of it. For most part now, all of the asphalt contractors that we deal with on contract construction work have their own labs at their plant sites. Very few of them hire any work at. The lab is required to be certified by the department. Realize that it's a separate certification from the plant. Bob just covered with you the requirements for plant certification. The plant gets their certificate, and the lab gets their certificate. Two separate certifications. So realize that you can in fact have a certified plant without a certified lab, and you can in fact have a certified lab without a certified plant. Now we don't have much of that. We do have a few instances of it. We have a few smaller producers in the state that like to be able to say to their customers that they are NCDOT certified. They get their plant certified. They don't have a lab. They can't do any contract construction work because they're required to have a lab if you do. So they get their plant certified. We've got 2 or 3 of those scattered across the state. And then labs that are certified without a plant, I think we have either 3 or 4 of those, but all of them belong to consulting firms. a couple of consulting firms in Raleigh, I know one in Greensboro, have certified labs, and of course they hire out to do asphalt testing out of their lab. Our section is responsible for the certification of the lab just as we are for the plant. We handle it a little differently than we do the plant. Bob told you that with the plant certification, normally one of our 3 pavement construction specialists out of our section goes out and checks the asphalt plants. For labs, we normally utilize the local QA supervisor to check the lab for us. QA supervisor are naturally very familiar with the lab requirements because they run one themselves, and so they know what the requirements typically should be. Normally, we have a lab that's requested to be checked. We contact the local QA supervisor. He uses a standard checklist. All of them have the same checklist that we furnished them. They go to a lab and they check it by that checklist, and if they're satisfied it meets the requirements, they submit it back to us, and we review it, and if we are in agreement, we issue a certificate, one on page 7-8. The lab certificate looks like this. We require that the contractor post it on the wall in the lab so it's visible to anyone that comes in. Just as with the plant certification, no expiration date. It's valid until for some reason it doesn't meet the requirements any longer, and then of course we would revoke it. I would say that the labs are checked. If mix is being produced out of a plant and tested, the lab's checked 2 or 3 times a week normally. Realize that our QA personnel are in a lab. If it's active, they're in the lab several times a week picking up samples and things of that nature. And they don't recheck the entire checklist every time because they don't have time, of course. But they sort of monitor what's going on and they spot check things. So we keep a pretty close check on the labs to be sure they continue to meet the requirements. One other thing I'll point out to you, the certification number, you'll notice down in the lower left, that number starts with the SP. SP tells you that lab certified to do what? Test super pave mixing. Realize that before super pave, the Marshall method of mix design and testing was the procedure that we used, and we had certification requirements then just like we do now. You know, we certified plants, we certified labs, we certified technicians. We sort of had to change our process. With Marshall method, that lab just had a series of numbers down there. All we did is when he converted that lab to super pave to meet the requirements, we put an SP in front of it. Early on, that meant a little bit of something to you because for a while we had labs that were just certified to do Marshall work but hadn't converted, and then we had some for super pave. For the most part now, all labs are set up to do super pave mix testing. Any question on the labs? Our labs, our DOT QA labs, we do not have an official certification process as such for those. We somewhat rely on the materials and test unit to monitor our labs for us. The asphalt design section in the M&T unit has to maintain a yearly MRL certification, which is very stringent, by far more stringent than any certifications we got for contractors and us, but they have to maintain that certification on a yearly basis. So we somewhat ask them to help us out in being sure our 14 labs sort of stay current and up to date. And so they do that for us. They just spot check them occasionally and monitor them to be sure that they are up to date and current. I would say most all of our labs are very up to date, got some of the most current up to date equipment that we can get. With that, we'll go to page 7-9. On page 7-9, you'll see what's called a plant sampling schedule. It's a summary of all the test procedures, test requirements. As I said, the actual test procedures the technician is required to follow is written in section 7 here. All the different test procedures are in the book. Naturally, you can go to each one of them and find out for that particular test what size sample you're supposed to take, where you're supposed to take it from, how you're supposed to split it, and that stuff. All we've done is gone to every one of them and summarized it. So it's on one sheet of paper, makes it a lot easier. A lot of lab technicians will keep this up on the wall. It helps them to be sure they don't miss a test or get the wrong size sample or something of that nature. Again, you're going in plant work, good reference material. On 710, we get into the sampling frequencies. As I mentioned earlier, we don't spend much time on the frequency of test sampling, with this one exception. We're going to cover the actual frequency of sampling the mix itself, because that's a very important part of the process. As we mentioned earlier, quality control is a lot of upfront work, but then we do in fact test the mix to be sure it meets the requirements. This is our procedures for taking the samples before the test is performed. How often we take the samples. Before I get into the actual frequency, point out one spec requirement related to that. This is the second sentence in the second paragraph. It says all tests shall be completed within 24 hours of the time the sample was taken. If not within this time frame, production shall cease until the tests are completed. Our spec says that once the technician takes the sample, he must have it completed within 24 hours. If not, we stop until he finishes. That is a spec requirement. I would say apparently it's not a very stringent spec requirement, because to my knowledge, since 1994, when we started QMS, we've never had to stop because the technician didn't have the test finished in 24 hours. It's an ample amount of time. Realize that when the technician takes the sample off the truck, normally most of them start to work on it pretty soon, and it takes about 3 to 4 hours to run what's called a full test series on the mix. So 24 hours is an ample amount of time. Before we get into the frequency, let's address the two different types of test series. We do two different types of test series on the mix itself. One's called the full test series, and the other the partial test series. If you look over on page 711, you'll see those two listed. First, you'll see the full test series listed, and then the partial. For the most part, they're just what their name implies. The first is a full set of tests, and the other is just a part of that. The full test series, the technician takes approximately a 200-pound sample. That's a fairly large sample. Just to give you a feel about how much it is, it's about 4 or 5 gallon bucket tools. It's about how much mix we're talking about that he takes when he takes the sample. And from that, and we'll get into the quartering and split process in a few minutes, but from that, he checks the binder content, he checks the gradation of the aggregates in the mix, he runs a maximum specific gravity test on the mix to determine the maximum gravity. He takes some of the mix and compacts a set of 3 specimens with the gyratory compactor. It's the same process that you saw in that mix design video. They're required to have that same piece of equipment in the field lab, and they gyrate 3 specimens out of a full test series, and from those 3 compacted specimens, then they calculate the volumetric properties, which for most part are about E through I. The things listed there are calculations based off of those 3 compacted specimens. So a full test series is, he checks the binder content in the mix, he checks the gradation of the aggregate in the mix, he runs a maximum specific gravity test on the mix, and he compacts a set of specimens and checks the volumetric properties. That's a full test. A partial is only a check of the binder content and the gradation of the aggregates. That's listed under your binder there. Under your partial. Binder content and gradation. Any questions on those?
That's what's required, but sometimes we actually utilize just the AC content.
Right. Now this is a good point. Our specs require a minimum, and that's what we address as we go through the requirements. Contractor can do other tests at will.
Like do for consistent if there needs to be a change.
Right. Some contractors, just to give you an example, I know she's saying like today, sometimes they just pull samples to check the binder content. The binder content tells you a lot about what all those other things are. But some contractors do not run partials. When they're required to take a partial, which we'll go over that in just a minute when you're required to, but when they do, instead of it, they run a full test. That's fine. The minimum is the partial. But again, good point. We cover minimum requirements here. The contractor can do more, which is very good. With that in mind, we'll go back to the frequency now. Back over on page 710, in the middle of the page, it addresses the frequency of sampling for full test series. In that blocked off area there, right above that, it says the contractor shall sample and perform a full test series on the completed mixture from each mix design per plant per year at the following minimum frequency, and it says he takes one sample out of every how many tons? One sample out of every 750 tons of a mix design out of a plant per year. So if I'm running a mixed design, when I start at the beginning of the year with whatever that design is, that mixed design, I just start every 750 tons of it I run out of my plant, I'll take a sample of it and test it. Realize that a lot of contractors have the same designs issued to different plants. Sometimes they have several plants in the same general area and they're using the same identical materials, and they run the same design. That's a different job mix formula number, but that number out there on the end will be different, but the design number is the same. So let's say we're running the same design at two different plants. I keep up with mine every 750, you keep up with every 750 yours. We don't worry about each other. It's by plant, and we start over every year. The only reason we do that is just for simplification purposes. You know, you can take one out of every 750 for that design forever, as long as that plant kept running, but after a while that number gets to be about, you know, it gets bigger, bigger, bigger. After a while you keep writing that block. So to just simplify things, we just start over every year so we can keep the numbers under control. A partial, the frequency of partial is addressed in the paragraph below that. In the middle of that next paragraph, it says when daily production, this is about middle way to that next paragraph, it says when daily production of each mix design exceeds 100 tons and a regularly scheduled random sample location for that mix design does not occur during that day's production, then you perform a partial. Sort of long, wordy sentence, sort of hard to follow there. I'll try to better explain that to you. The full test series is off a cumulative tonnage. You know, every 750, you're going to keep checking. You're going to keep checking. It's a cumulative. It doesn't matter when it occurs. The partial is a daily check. It's something that you check for of a day. It says that when you start up on a day, if you produce more than 100 tons of a design, but you do not get to where that full test is to be taken in that increment, then you take a partial sample and run the binder and the asphalt content, the binder and the gradation on it. Give you some numbers. This makes it even easier to follow, I think. Let's say in this 750 ton increment, I've determined that my sample is to come at 500 tons. That's where I've got to take my full test series sample. And I start this morning and I run to the 300 and the plant breaks down. Did I exceed 100? I did. Did I get to the full? No. So I have to take a partial. That's what the spec's saying there. If you exceed 100 and don't get to the full, then you take a partial. The idea there is so that you won't. It's possible if you stop and think about it. You know, you could have a 750 ton increment and just be by chance the random sample come at 740 or something way out there at the end, and you could have several just barely over 100 ton days and never have any kind of test on it if you watch something in there. And that's what it's trying to prevent. But most of the time, well, not most of the time, but if you have a full test, you don't take a partial. If you run over 100 tons today, you're going to do one of the two, though. You're going to either take a partial or a full, depending on whether it gets full or not. With that, we're going to go into how you determine where to take that full test series sample. The partial can be taken by the technician anytime he goes past 100 tons of a day, as long as he gets one before production stops that day, he's met the spec. There's no set procedure of when and where to take it after that point in time. But for your full test series, there's a random sampling procedure that we require that the technician go by to determine where he takes it in that 750. And we'll go over that with you. If you turn to the next page, over on the bottom of 712, you see down at the bottom, in the middle of, well, it's in the second paragraph, it first tells you in that first sentence that the procedure that we use is ASTM D3665 Alternative 2. And then in bold print it says this is the only acceptable means of determining random numbers for the plant mix test location. I told you earlier today that we use ASTO and ASTM test procedures. We elected to use the random numbers procedure out of the ASTM book. If you'll turn over to the next two pages, on page 714 and 15, you'll see the set of random numbers that we use to determine the sample location. What's the purpose in using random numbers like this, random numbers table? Why don't we just say to the technician, you take it at random somewhere out of the 750. Exactly. That's just dead on it as you can get it. Whether we want to admit it, we are. You know, maybe yesterday you said something I didn't think very much of. This morning I pulled that first truck over, you know, just to keep that kind of stuff from happening. You follow the procedure. There's no ifs or buts to it. The sample must be taken from wherever this procedure says, and the technician can't vary it, or he's in violation of the spec if he does. Realize, too, that the way random samples are set up, well, we'll just look at our table. We've got 2 pages here. We've got 2 pages of numbers. If you utilize the entire table, the way the system is set up, if you utilize the entire table, you will, in fact, half of your samples will come out the first half of the increment, and half of them will come out the second half of the increment, but they'll be just scattered at random throughout. But you will have equal representation scattered, half in the first, half in the second. That's sort of the way the process is set up. How it works, we elected, there's several procedures in the ASTM book on how you can use the table. We elected to use the one that said you start in the upper left-hand corner with the upper leftmost number, and you work your way straight down that column of numbers using them until you complete it all in that column, and then you come back and start at the top of the next column and repeat the process. You know, there's one procedure in there that says you can start in the lower right-hand corner and go up. One in the upper right-hand corner. It's just different ways of using the table. We decided we'd start over on the upper left and work down. We always start with 0.245. That's our first number there. For our first increment of a mix design at the beginning of the year, you're going to multiply the random number times the increment, which is 750 in our case, and wherever that result is where the samples will be taken. In this case, it's 184 tons. We just figured to the nearest whole ton. Realize that the best the technician can do is take it out of the truckload that has that tonnage on it. You know, that's all they can do, and that's what we, you know, expect them to do. So he figures it, and it's 184 tons. He takes that sample out of that truck that's got 184 tons on it, and he runs his full test. How many tons of mix does that test represent? 750 tons. No matter where it came from in it, it represents all 750 tons when he finishes that. So now we go to our second increment, and we use the second number below, which is 0.539. We multiply that times 750. It's, if I remember correctly, it's 404. So where do we take that sample? It's 404 into the second increment, so that means I've got to add that 404 to 750, and it's at 1150, where you're using a cumulative tonnage, and you just continue that process is all you do. The next time, I multiply my number times 750, I add it to 1,500. The next time, I'll get my number, I'll add it to 2,250. Next time, I add it to 3,000. That's all the process is. Any questions on that? The technician, like I said, for the most part, is required to take a sample at that location once he determines that location. And realizes when he uses a number, they're required to mark through it, and that's how they keep up with which ones they use, is to go down through there, they draw a line through them as they use them. There's a couple of instances where he may take a sample at a different location, and I'll cover those a little bit later as we go through the section. But generally, by the specs, he's to take it at that location. Over on page 718, we talked a little bit about our mix verification requirements. Our specifications require the contractor to, if you want to say, field verify a new mix design before he begins normal production. This applies to a new mix design. That means one that's not been produced and tested before. If it's one that's been produced, tested, this doesn't apply to it. The spec says that before he can run a new design, that he must in fact run it through his asphalt plant and basically prove to us that that mix goes together going through that plant the same as it did when they put it together in the lab during the design. If you think back to that design presentation this morning, you know, they use pretty small quantities of material work. They get them out with a scoop, weigh them up, pour a little bit of binder in there, and either stir it up by hand, or sometimes you got these beaters that you use to stir it up with. Well, this is a different ballgame now. Once we're sending tons and tons of material through this big asphalt plant. And sometimes the stuff just doesn't go together the same as it did in the lab. And we just want to be sure that that doesn't occur. What you hope happens is that your design is in fact representative of what's going to happen in the plant, and it goes through there and comes out and you get the same results and everything works well. Sometimes it does. So just to be sure, we require that he field verify it before he starts normal production. As you see in that first sentence there, it says this must be done within 30 days before he begins production of a new design. For most part, the requirement is that he gets a sample of the mix and runs a full test series on it and checks it out. Now, there's some other things involved. If you read through there, you'll see it says that in addition, he has to calibrate the cold feeds. He has to be sure the scales have been checked and are in calibration. He has to check all of his equipment to be sure that's not a problem before he does this. But then the main requirement is that you run the mix through there, run a full test series on it, and see if it works or not. If it does, fine, we start normal production. If it doesn't, then we make adjustments to try to get it to work. And we'll talk a little bit about adjustments next. Turn over to the following page, and you will see allowable mix adjustments. Realizing that there will be times when we have to make adjustments to the mix. Some of those are at initial startup, just like we talked about. Sometimes that mix doesn't go together the same as it did when you designed it, and you have to make adjustments. Sometimes you have to make adjustments later on. I mean, nothing unusual to have been running a mix for a while and everything been going smooth, and all of you don't know it. They change the screen at the quarry on you or something and send you a little bit different graded material, and it screws your test up, you know. It gives you different results, and you have to make adjustments. Well, those things are going to happen. Knowing that, we just sort of tried to come up with a set of rules of who could do what here. I'm not going to go through them in detail as to what they are, just to sort of give you an idea. They're sort of set up such that minor changes can be made by the contractor without asking the department. That's the first thing listed there. It says that the QC can make those changes without asking the department. They're some of the more minor changes. Now, they're required to notify us of any change. The spec says that they must notify us, even if they don't have to ask up front, they still have to tell us they've made a change. But they can make those without asking. Then the next set of changes are ones that are a little bit above that. They can ask for those, and the QA supervisor is given the responsibility to make a call on those. The local QA supervisor can approve or disapprove the second set there. The third set, a little bit more major, those can be asked for, but they must go through one of those 3 pavement construction specialists that work out of our office to approve those. And then the last things listed are the most major changes that you might encounter. Any of those have to go through the pavement construction engineer, who is the head of our section, who currently is Wiley Jones that we work for. He makes a call on those. I would point out to you that for most part, when you verify a mix, we just talked about the field verification requirements. A new design has to be verified. If you start a mix after you verify it and you never have any problems with it again, you don't have to re-verify it anymore. It's just an issue. There are some changes, though, some of those last changes that are listed that are very major changes to the mix that we require the mix be re-verified before you start production. And it's got them noted down there at the bottom. But when you make a major change to a mix, for most part, we do require it to be checked out again before you start sending it out there. Over on the next page, we get into our control charts. One of the plant technician's duties is to plot some of the test results that he has from his test procedures. We required the results that we feel are important to monitor to be plotted. What's the purpose in plotting these test results? Let's say, well, I'll tell you that the graphs we use to plot on will handle 25 tests, 25 results on one graph. What's the purpose in that? If I've got all 25 of these tests on a sheet of paper in a stack laying there, what does it benefit me to have them plotted on a graph? I think everything I've heard is somewhat correct. It helps provide consistency. It allows you to monitor for control purposes is the primary thing. You can see all the data at one time. You cannot remember all the data at one time. You know, you just can't possibly remember all of that stuff that's in that stack of paper. But if you plot it, it's got it up there in front of you, and you can see it all at one time. And I'm going to go over a graph with you to sort of show you how it's done. But the primary purpose in it is to try to monitor the process, to watch for trends, hopefully that you might see something coming and be able to stop it. You know, if you begin to see results going out on the high side or the low side or whatever, that you may see that up ahead of time and be able to do something about it. That's the concept. The graphs that, well, I want to drop that thing. We have 2 acceptable means of plotting the test out. The technician can plot it manually on a graph, hard copy graph. We have a computer spreadsheet program that we offer to the industry or anyone that wants it, and it will plot the graph. Now that spreadsheet program does a lot of other things. This is just one of the things it does for you, but it will plot the graph for you as well, and I'll show you some results off of one that's plotted by the computer spreadsheet program. But he has that option. We do not require the use of computers yet. I think that's coming eventually, but we do not as of yet. So he still has the option of manually plotting. If I was a technician, I'd be begging for that computer. That manual plotting process is sort of a job. This is the hard copy that we use. This is a blank one. It's self-explanatory copy. You fill in the information. The technician plots his data around this dark horizontal center line you see here. Our specs even specifically say that that line on the graph must be the target of whatever you're plotting. That way you've got the most use of the graph. If you're plotting binder and say your target on your formula was 5%, that line represents 5%. If you're plotting the .075 sieve and that's 4.2, that represents 4.2. Whatever your target is for what you're plotting, that's the line there. He plots his individual test results, and like I say, if you count across there, you'll see you can get 25 test results on it. He plots his individual test results, as well as a moving average of the last 4 tests. We use a moving average concept to sort of monitor trends. Moving average are used a lot with quality control, quality assurance type programs. Realize a moving average is different than an average. You know, if you average something, you take all the numbers you've got and you add them up and divide them by how many numbers you have. A moving average moves with the last X number that you're dealing with. We elected to use the last 4. You could use the last 3, the last 5, or whatever. What's the purpose there in just using those last 4 or last few numbers?
To see if each test still is going to be within range of passing.
Well, not only that, it's the
samples you ran last month don't count what you did.
exactly. You know, if I'm using that average to sort of try to watch what's happening, and I'm going to try to fix it before it happens. I don't care anything about what happened 6 months ago. You know, that has no effect on what's going on here in these last few tests. So you just look at the last few tests. We pick there again. We pick 4 to look at, and that's sort of the concept there. Show you some of that in color. This graph is in your manual. It's on page 725. Yours is not in color. Mine is. This would have been, if we'd had it that printed in color, that would have been the only page in the manual that would have been in color. It won't worth the money and trouble. So it's black and white for you. Maybe you can tell better from what it looks like by looking at mine. This is a graph that was printed by our computer spreadsheet program. And like I said, we offer this graph, this program free of charge. Anyone that wants it, you just ask us for it. You can download it off our web page. The program is on our web page. You can simply download it right off that web page and use it. If you can't get it from there, you can call and ask us and we'll send you a copy of it. But one of the things it does is plot the information. The technician sort of puts the test data into the program and it calculates it and then it takes it over there and puts it on this graph. It draws the lines and everything on it. The lines that we're looking at, well, first, back to the center line. Remember, this is our target line. Here, we're checking the .075 millimeter sieve, and the target was set on 4. That line represents 4. Then we plot what's known as the moving average limits, and then the individual test limits. If you look on page 722, you'll see a set of control limits there in the boxed off area. These are our control limits. You have two control limits. One is that moving average limit, the other is the individual limit. The moving average limit applies to the moving average of the last 4. The individual applies to the individual test. Here, we're using the 075. If you look in the table, the 075, the moving average on the 075 is plus or minus 1.5, and the individual is plus or minus 2.5. So we come on our graph and we go up 1.5 from our target, and we draw the dashed green line. The dashed green line represents the moving average limit. We come down 1.5 and we draw another dashed green line for the bottom side of the moving average limit. And then our individual limit was 2.5, so we go up 2.5, draw a dashed red line, which is our individual limit, and down 2.5, and another red line for the bottom limit. Then the technician plots his data. He plots his individual data in black and connects the points with a solid black line. That's his first result, which was 4.5. This one was 4.3. That one was 4.4. That one's 4.8. And he just plots them and connects them with a solid black line. His moving average starts at test number what? 4. You can't have a moving average of 4 until you've got 4. So you don't have a moving average on the chart until you run 4 tests, and that's where your first one will occur. Here, I have averaged tests 4, 3, 2, and 1, and it averaged 4.4. That's my moving average. I run test number 5, and I plotted it. It ran 4.0. Connect with a black line there. I averaged test 5, 4, 3, and 2, and I drop 1. The last 4, and I plot that as my next red one and connect it with a solid red line. And I just continue on like that. I plot the individual, and I average the last 4. Only the last 4, and that's my moving average line. To sort of give you a feel of what the specs are, this is very simplified, but basically the spec says to the contractor that if you'll keep your individual test or your solid black line inside the individual control limits, which is my dashed red line, and you'll keep your moving average or your red line inside the moving average limits, which is the green line, you read the spec. Very simplified. It's not written quite like that, but that's basically what it is. If you keep the individuals inside the individual, moving average inside the moving average, you keep running, you're going to get full pay. Basically what the spec says. Now, there's provisions in there, of course, of what to do if that doesn't occur. All the graphs don't look like that one, I can assure you. That one looks really good compared to a lot of them. Some of them are a lot more erratic. Naturally, sometimes you don't meet the requirements. The section of the spec that addresses what to do when you don't meet the requirements is called a corrective actions. And you'll see beginning right beneath that control limits table, the next heading there is corrective actions. From there to what's the end of 724, all of that is word for word out of our spec. We just copied it right into the manual. That's the section in the spec that tells the contractor, if you don't meet the requirements, this is what you're supposed to do. Now, it addresses about anything you can possibly think of. If an individual is out of the individuals, if 2 is out, if a moving average is out, it covers all of that stuff there. I won't get into any details at all there on that process. That's the part of the spec which tells him what to do if he doesn't meet the requirements. Any questions on the control chart and plotting the data? Beginning on page 726, sampling procedures. If you thumb through the next several pages, as you go through there, you'll see a lot of sketches. There'll be rectangles, circles, ovals. This is the pages in the manual that tells the technician how to take the sample and where to take it. And again, we won't go into a lot of details here in this class, but for most part, his full test series is a 200-pound sample. He takes it in 4 buckets, as we mentioned earlier. 4 or 5-gallon buckets are used to sample with, and then that mix is separated into different parts. One of those bucketfuls of mix he uses, the QC technician uses to do his test, his QC test. One of the buckets is set aside at the lab for what we call a referee portion, and the other 2 buckets are set aside for possible pickup by our QA personnel. As I said possible because we don't pick up everything. Our QA person comes in and he picks up some of it at random. He takes it back to our lab and retests it. And if for some reason our test of that mix doesn't match up to his result, then that's where that referee portion that he set aside there in the lab comes into play. That way we've got some more mix left that we can go back to and hopefully resolve the problem. A lot of times when we get to that point, we run that test jointly, either his lab or our lab, whatever's agreed upon. On page 731, you see all the test procedures listed. These are the ones that the technician is required to know how to perform. As we said earlier, he doesn't have to do all of these every day by any means. The test procedures are written for there. For the next several pages are the ones that the technicians are actually required to follow. This is just sort of for you general information. Part of our QMS program is independent assurance sampling. We have a section, it's called the IAS, Independent Assurance Sampling section, that their purpose is to monitor the technicians' test procedures. They go around and watch technicians run tests and be sure they're running the test correctly. They don't have anything to do with acceptance of the mix or anything like that. All their job is to be sure that all the tests are doing correct. Everybody's doing them the same and we're doing them correctly. These are the actual test procedures that they go by, that they expect the technician to follow. For our purposes, as I said, we're going to skip over those. We're not going to cover test procedures at all. We're going to go all the way over to page 776. Everything you just skipped was test procedures, or some of the last few pages were calculations that go along with those test procedures. Here are allowable resampling and retesting guidelines. As I've said, for most part, technician is not allowed to change the location of the sample or to decide he's taken a bad sample and just get another one in the place of it. He just can't do that. Once he determines that location of that sample, he must take it at that location. And once he takes the sample, he must test it. And when he tests it, he must report it. The spec requires all of that. It's got to be taken, tested, and reported. He is not allowed to resample as such just because he thinks there's a problem of any kind. The only time we allow any resampling is under these guidelines. The concept here is that if the technician gets an individual test result, and that individual test result is so far out of whatever is required it to be, that if it's proven correct, there's no doubt that mix is going to be coming up. Then we allow him to retest. The idea there is that before we take up some mix, let's just be sure it's bad. You know, it's a benefit to the contractor, obviously, to get to retest in those cases. But at the same time, it's a benefit to us or the taxpayer, whoever. It doesn't do us any good to take up good mix. You know, if it happened to be a fluke result, we don't need to take it up. You know, and we're just allowing the contractor to check to be sure before we take any up. To give you an illustration, we'll look at the first numbers there for VTM. The table says that if he gets a voids, a VTM, voids in the total mix, what are our voids typically set on for super pay? 4%. It says that if he gets a result that is off from that by more than plus or minus 2.5 from the target, then he is allowed to resample and retest. On the high side, if my target's 4, I'd have to have a voids of what or higher? 2.5. 7.6, because it's got to be more than 2.5, it says. So it would have to be, let's say 6.6, 6.6 or higher. And on the bottom side, 1.4 or lower, because it's got to be more than 2.5 on that side. And if you know anything about voids, you know those numbers are terrible. I mean, that's obviously an unacceptable mix. And I'd say if that's proven to be correct, then the mix is coming up. He is allowed to resample and retest. He is not required to. It is an option of the spec. Sometimes they have a test result and they know what's wrong. You know, if you have liquid asphalt running out of the truck when you took the sample, it's pretty obvious you got a problem. You get 0 voids, then you no need to try to retest it. We've had several instances where they knew what was wrong. They didn't resample and retest it. But I got the mix up. Went on from there. But if there's any doubt, of course, they are going to resample and retest. Where are we going to get this mix from that we're going to resample and retest? Where's it going to be by the time we know our test result? I told you earlier, it takes about 3 to 4 hours to do a full test series. It's out there already put down. Usually it's already on the road and it's already put down. So you're talking about taking some mix up off the road, and usually that's what occurs. You either cut it out with a core machine or cut it up with saws or something of that nature until you get enough of it cut out and cut up to perform a full test series. The bottom of that page and all over on the next page are guidelines on how to do that. We've got specific procedures to follow when this occurs. I won't get into any details there of how to go about doing it, but those are the rules and the guidelines of how to do it in those cases. Over on the next page, 778, the last thing we'll cover is quality assurance. What do we do in the way of quality assurance to ensure that we're getting correct results from the contractor? It lists 6 things there. First, it says that we conduct assurance testing of split samples obtained by the contractor at a frequency equal to or greater than 5% of whatever his frequency was. Those are the splits that I just talked about a few minutes ago, where the technician takes the 4 different bucketfuls of mix off the truck. If we pick up a part of that, that is a split sample. That's what it's talking about there. We'll do that at least a frequency of 5% or more, whatever he says. We'll observe his sampling and testing procedures. Our QA personnel still do some of that. As I just mentioned, though, we now have a fairly active IES section, and their primary purpose is to monitor test procedures, so we don't do as much of it as we did. By monitoring required control charts, realize that our QA labs all use our spreadsheet program. Contractor is required to fax in the test data to our QA lab by the beginning of the following day after he runs the test. They simply key that information right into that spreadsheet program. If they want to go check your graph, they're going to print one out before they go. They've already got it. They know exactly what it's supposed to look like when they get there, because they've already put that data in the program, printed the graph. Very easy check for them, but a good check. Number 4, by directing the contractor to take additional samples at any time, any location. Our specs are very plain that the department can, in fact, direct samples at any time we want a sample. For the most part, though, we try not to cause that to generate extra samples. You'll notice that it says in parentheses, in lieu of the next scheduled random sample for that increment. Let's say I come to a plant and I want to, for some reason, watch the technician run a test. And when I get there, it's 600 tons before the test is scheduled to be taken. Well, he can't take it at any other time besides when it's scheduled. So I tell him, you pull that next truck over and get a sample on it, and you test it. I watch him run the test, and he has to do it. It takes the place of the one of 600 tons fall. Just a different time, but it still represents that increment. By testing verification samples with a frequency of 10%, that's number 5. For plant mix, verification sampling, remember, that's what I call our independent sampling. It's separate and apart from what the contractor's doing. For plant mix, typically what's done is when the QA person's at the lab, they will just flag a truck over to the sampling platform. Our person takes the sample, they bag it, they take it back to our lab and test it. The contractor doesn't have anything to do with it. It's just a separate sample taken by our person and tested by our personnel. I would say that even though we're not required to, the general guidelines to our technicians is that you take a sample twice as large as whatever you need and offer the contractor half. And they stand to do that. It's up to the contractor whether he takes it, doesn't take it, test it, doesn't test it. We really don't care, but we're going to test our parts for it. That's the verification sample of the plant. And then a combination of all of the above it says, of course. And for most part, that gets us through section 7. Any questions on anything we've covered there?
Next section in manual, section 8, is titled Recycling of Asphalt Pavements. As I mentioned this morning, the DOT does highly encourage contractors to use recycled mixes, especially this day and time with asphalt prices being so high. And it just makes that material, even more valuable than ever before. The basic concept in designing a recycled mix is that you recognize that mill material, or ever how that old asphalt is accumulated, acquired, whatever, you realize it's old and usually old and aged and oxidized, the binding is real hard. And so the basic concept is to combine it with new materials in such proportions and using softer grades of asphalt than you typically would for a given mix type, such that the combination will give you a mix that does meet the gradation requirements for the particular mix you're looking for, as well as that blended old asphalt and blended softer new asphalt will give you the grade that's typically required for that particular mix type. And so that's the basic concept. Other than that difference, the specifications on recycled mixes are the very same as they are for the all new mixes. Mixes made with all new materials. And the way that works as far as blending is that the specifications allow a contractor to use up to 20% reclaimed asphalt material in a mix and still use the same grade of asphalt that was typically called for that particular mix type. If he goes above 20 and not more than 25, he has to use asphalt graded one grade softer than would typically be required for that mix. For example, if it was an S9.5B mix, was typically called for PG64 minus 22 asphalt, then he would have to use a PG 58 minus 28 grade. That's a softer grade on both ends of the spectrum. And then, excuse me, hopefully, when you combine those two together, it'll give you something that will be pretty close to a PG64 minus 22. In North Carolina, I would say that about 75 or 80% of all mixes produced do include some reclaimed material. The vast majority of those do use 20% or less, such that they can stay with that the standard grade of that particular mix. Asphalt recycling can be done in either batch plants or drum mix plants. The plants have to be modified, to accompany the recycling process. Most of the recycling is done in a drum plant today. And there are a couple of reasons there. One of them is the fact that most plants today are drum mix plants. About 90% of all the new asphalt plants that are purchased in the country, as I understand it, are now drum mix plants. And so I think that plant manufacturers have devoted most of their efforts toward developing the drum mix plants to accompany the recycling process. Along with recycling, and this is covered over at the end of this section, we have milling. Here we're talking about coal milling, where we take a milling machine and go out and we mill up certain portions of the pavement or all of the pavement, whatever, partial depth, full depth, whatever the case might be. And then that mill material is normally returned to an asphalt plant. In some cases, it may require minor crushing or processing to handle correctly. It normally be used directly into the asphalt mix itself and incorporated into the mix. But milling is a very helpful or beneficial maintenance tool. As I say, you can go out and you can mill an entire lane if necessary. You can mill partial depth, full depth. You can mill partial width. You can mill just distressed areas, and so on. In most cases, if necessary, you can go in and mill and repair those areas in the same day without having to leave them open to traffic overnight. In some cases, they in fact do mill maybe several miles of a project before they actually start covering that up. With proper traffic control devices and so on, that's okay. But it is a very handy tool to remove distressed pavement, leave the good pavement without having to replace that. It's a good tool when you to restore bridge clearances and guardrail heights and drainage features. Sometimes you have curb and gutter sections, I've seen them where they've been resurfaced to the point where the gutter lines are vertically covered up. You can go in there and build that out and restore the surface and overlay it. And you restore your drainage and so on. You can, it helps in areas where you have rutting. You can go in and build the rutted surface to restore a uniform profile in the pavement. So just all kinds of benefits to use for using milling. And then in addition, to restoring the pavement to a good condition, you can use that mill material in recycled mixes. Now, it doesn't have to be mill material. They can go out and remove asphalt from a parking lot or a front end loader for that matter, and take it back to an asphalt plant. Of course, it has to be crushed in those cases before it's incorporated into an asphalt mix. One of the major benefits to recycling is keeping that mill material and old asphalt out of landfill. Used to, we would bury it in a landfill, put it in a landfill, waste it in a landfill, or waste it in an embankment or whatever. But in most cases today, it's recycled and incorporated back into an asphalt. Again, as I said, today's prices is makes good sense. Makes good economic sense. If you just think about it, as I mentioned earlier this morning, a ton of asphalt binder at today's prices, let's just say it's $500 a figure. Most of the mill material that we take up is surface has on the order of about 6% asphalt. So what is just an asphalt binder alone in a ton of wrapped work? 6 times 6 times 5 is 30. Just the asphalt alone in a ton of reclaimed material today is on the work on the order of $30 to $35. Not counting the aggregate, which is probably another 15 to 20. It's a very, very valuable product. In addition to using reclaimed asphalt material in pavements, we've also recycled shingles, tires, glass, old concrete, broken up, taken up, and so on, crushed and reused, slag, and other materials. I mentioned shingles. There are several contractors now that are incorporating waste shingles, waste manufacturing waste from the shingle manufacturing process, taking that material and grinding it up real fine, and incorporating that into an asphalt mix. It's a very good, very strong, durable asphalt mix. The quality of asphalt and shingles is very high. You have that fiberglass, whatever it is, and there's backing on the shingles, and that's ground up and incorporated into the mix, acts like almost like a reinforcement in the mix, and so on. So it makes a very good quality mix. Very rut resistant, and perform very well. As I say, the shingles that we have used here in North Carolina today is waste from the manufacturing process. In other states, and I would sort of anticipating that North Carolina will eventually do that, are developing ways to incorporate what I call tear-off shingles, replace shingles, in asphalt mixes and for other things as well, I'm sure. But when you think about it, just think about the millions and millions of tons of shingles that are out there that someday are going to have to be replaced. And something has got to happen to that material. And if you could incorporate it into an asphalt mix and make a good mix and do it economically, that would be the thing to do. As I mentioned also, we've recycled tires. There's a lot of waste tires, just like shingles. You can grind those tires up fine enough that you can incorporate them into an asphalt mix, and it will, if it's done correctly, will perform very well. One of the major problems there is that it's very, very expensive to grind those tires up almost like powder and remove all the fabric and remove all the reinforcement, steel, this kind of stuff out of those tires and be able to incorporate it into a mix. Very expensive to do. As I mentioned, we recycle a number of other things. And as long as it's done correctly, with shingles, tires, reclaimed asphalt pavement, whatever, recycled mixes are just as good a quality as mixes made with all new materials. You have to do it correctly. You can't just toss it in there and hope it'll go away. Any questions about recycling? I have gone through that real quick, and I will just tell you that I don't think there are any questions on the test that are related to recycling. With that, I'll turn it over to Bob. You do use a wrench to put this thing on? If you would go to section 9 of the manual. One told you when he went into section 7, if you're planning to go on to be a plant technician, that section 7 was the section that you needed to be most familiar with. The next two sections of the manual, 9 and 10, deal with the roadway paving operations. So if you're going to be a roadway technician, these are the two sections of the manual that you're going to need to be most familiar with. As I said, we're going to start off in section 9. It'll tell you there in that first paragraph of section 9 that this section deals with your paving operations, including planning, equipment requirements, and things like that. There's different things that need to be brought out front at the pre-construction conference and before the paving operation actually begins. Also in this section includes prime and tack. That's what we're going to talk about mostly right now. And Jim will touch on some of the other aspects of section 9 a little bit later. Instead, we're going to talk about prime and tack. Before we get into prime and tack, there's a piece of equipment that we use to apply both prime and tack, which is the distributor. We use a distributor, which is a tank that's mounted on a truck,
There are several requirements, have burners to keep the material hot, pumps, valves, and just different things like that. But we're going to talk mostly about this area back here, spray bars. Spray bars are very important to make sure that you get a good uniform coverage of either prime or tack coat. All right. The spray bar system is a series of nozzles that are set at a certain angle. As you can see here, these nozzles are approximately 4 inches apart, and they're set at different angles, depending on the type of coverage you want to make. You've got to make sure that these things are in good working condition, set at the proper angle, and that they are the right type of nozzle for the application that you're going to be using. As you see here, there's different coverages. You got your single, double, triple coverage. We do not specify any particular coverage. That's up to the contractor. The only thing we say is, Mr. Contractor, we want a good uniform coverage over the entire width of the area that we're going to pay. But in order to do that, you've got to have the angle here, the right nozzle, proper pump pressure. If you do not have pump pressure from the pump to force that material through those nozzles, then all you're going to do is get dribbles out through there, and you're not going to get that uniform coverage. It's a spray application of a low viscosity asphalt with an untreated non-asphalt base course. For example, you got your soil bases and ABC bases. This is a picture, kind of bright there. I don't know if you can see it well or not. This looks like some ABC that has been primed. Pretty good coverage. Looks like they got some slack spots in places, but it makes, all in all, it looks like a pretty good uniform coverage. Four primary purposes of a prime coat is to waterproof the surface, prevent surface water from penetrating into the base of subgrade material, seals voids, and coats and bonds loose particles, stabilizes that surface that you're going to be priming. If you go out and set up ABC, what do you use to set up ABC? Water. Water. When you get out there and start setting that ABC up, you put a vibratory roller on it. What's going to happen is it's going along there. It's going to bring the fines up to the top. And when that water dries out of it, what are you going to have left on top? You're going to have this loose bonded material particle. If you do not have them stabilized, and you put that first layer down on top of it, and you get ready to compact it, what's going to happen? Instead of going down like you want it to compact, it's going to go out. It's going to push out to the side. Instead of paving a 10-foot wide road, you wind up with an 11-foot wide road. It'll only be about half as thick as it's supposed to be. So you want to make sure you get good coverage there. Provides temporary coverage in case there's a delay in the paving operation. And again, it provides some adherence once it has, the water has evaporated out of the prime coat. Binder is left there, and it does promote some adherence. when do you need a prime coat? Generally, with the first layer of asphalt mixture being placed on a non-asphalt base is 2 inches or less in thickness. Again, you mentioned the pavement management unit. They are the ones that determine if a project needs to have prime on it. And they have determined that once you get above 2 inches, that the mix itself is heavy enough to hold it in place. So if you're less than 2 inches, then it needs to be primed. Prime coat must meet the requirements of Article 1020-3. There is a list of the approved sources of prime that we looked at this morning when we looked at Section 2. There are only 4 approved sources on that list at this particular time. Again, you need to check with M&D if you don't have one of those particular brands that were on that list we looked at this morning. Application rates. Prime coat is a fairly heavy application. It's applied openly uniformly at a rate of 2/10 to 5/10 gallons per square yard. You're talking about a 3x3 area, putting about a half a gallon or up to a half a gallon prime coat on. So that's a pretty heavy application. The exact rate of that prime coat application will be given to the contractor by the engineer prior to beginning that priming operation. And it will be given to him to the nearest hundredth of a gallon. So he may say, Mr. Contractor, I want you to prime this in 3,300 gallons per square yard. I want 2,500 gallons per square yard. He will let you know. It could be different on different areas in the contract. You might have a section over here that he wants 4/10 gallons per square yard. In this area over here, he may not want the 3/10 gallons per square yard. He will make that determination and give it to the contractor. Again, that's a picture of prime surface, good uniform coverage. This particular one is another area of prime. Prime coat is a pay item. We pay the contractor for the exact number of gallons he applied. If he goes out over this area and puts down 500 gallons of prime, we will pay him for 500 gallons, provided he is within that rate that's been established, between 2 and 5 pennies. If he overshoots it, then of course, that's his problem. There are calculations that have to be made to make sure that we are getting proper coverage, proper rate, the right number of gallons being used. There's a calculation example in your manual on page 9-7. As I said, we don't go into any calculations in this class, but we go into great detail in the roadway class on these calculations. Any questions about prime coat? Going along into Tack code, this is on page 9-8 through 9-11, the manual. Application of a liquid asphalt to an existing asphalt or concrete surface to remove bonds between the old pavement surfaces and the new pavement layer. This is a good picture of a good uniform coverage. Anybody in here ever seen a good coverage like that before, a prime coat up when a Tack coat operation? Not many times, have you? That right there, as Wayne says in other classes, this is not a made-up picture. This is an actual picture that was taken on the project. So that is a good uniform coverage. Three essential requirements for satisfactory tax application. The pavement must be sufficiently clean. Must get rid of all dirt, clay, mud, whatever that may be on the existing pavement. Because if you don't get it clean, when you put the tack coat on it, what's going to happen? The areas where that mud and dirt and stuff like that is, the tack's going to be sticking to it and not to the underlying surface. And eventually, that's going to break loose and you'll wind up with a big old pothole. We need to make sure that we've got the proper application. And again, the uniform coverage over the entire area that we're going to pave. I think I'm wearing it out, but it's very, very important that uniform coverage be obtained. Application rates for tack coat, they're a lot different than they were for prime coat. Prime was 2 to 5/10 gallons per square yard, where here our specs require to be applied at a rate of 400 to 800 gallons per square yard. That's a big difference. It's a very light application. Again, the exact application will be established by the engineer to the nearest hundredth of a gallon. Again, this is a picture of a good uniform cover. Has anyone here ever been involved in a tacking operation?
I haven't been per se involved, I just see my brother-in-law's been doing it for 30 years.
Whether you drive the truck, you're sitting there watching it or anything.
Yeah.
Do you see that all the time?
He does.
He does?
Yeah.
Okay, he's good.
He's really good, yeah.
The application temperatures, again, we have temperatures, here the temperature range for each grade. Of those 7 grades listed there, which do you think the contractor is going to choose? It's going to be one of these 6 down here, right? These are emulsions. Because you look, the first one here is what? That's 64 minus 22. That's the actual binder that we put into our mix. To get it so it will come through those spray nozzles, the temperature range has got to be about 400 degrees to have it hot enough. That's very, very dangerous. It's getting close to the flash point. And you don't want that stuff to flash. I tell you that. These others, you're talking about somewhere in the 120, 130 degree range. It's still hot, it will still burn you, but it's not as bad as something that's going to be about 400 degrees. So the contractor will be allowed to choose any one of these emulsions at this location here, unless there's some divisions which in their contracts they specify the use of PG 64 minus 22. So make sure you always check your contracts and find out if they have specified anything other than these emulsions here. Whatever's in that contract is what you have to do. You cannot apply more tack to be covered with base, intermediate, surface mixes during the same production day, except where public traffic is being maintained. What that's saying basically is if public traffic's being maintained, if you tack it, you've got to cover it that day. If you don't have public traffic, just construction traffic, then you may go a little bit further. Unlike prime, tack is not a pay item. It's incidental to the price of mix. But there's still calculations that have to be made by QA technicians and reported daily on his daily report. Again, these calculations will be covered in this class, so there is an example on page 911 in the manual. Is that a little more like it? Yeah. We've seen that a lot, don't we? Yeah. What I mean, make sure you get a good uniform coverage. How many times did he back up on that to get it that good? It's 2 or 3 times anyway, it looks like. So, you see, there could be several different things wrong here. You don't have the right pump pressure, wrong nozzles, wrong angle, something like that to make it street like that. So, make sure all that stuff on the spray bars are correct, and so you can get a good uniform coverage. Right here, it's like maybe this is a joint right here, traffic coming off here, when it hits in this area right here, what's going to happen? It's going to slide, slip, pop out, break my windshield. Yours too, maybe. Make sure we get a good uniform coverage. Any questions? If not, let's take about a 10-minute break.
Let's get it. It's getting where we can't even have to.
Not many people put that much pride in it. All they want to do is, I got to drive that thing all the way down there. Here we go.
When he gets in about 4:30 in the morning, his truck is loaded up, topped off, and stuff. Good stuff, like this is probably have to control.
We don't need this anymore, do we?
You're not.
Not yet, anyway. Okay. There's a lot of earth.
Grady uses this back here next.
Yeah.
Does that thing go over that thing now?
I was getting ready to ask that same
Absolutely
thing.
possible. Surely it is.
I was getting ready to ask the same thing. may want to check, I think you rewound that tape yesterday, but I'm not sure. Yeah.
We're gonna have to move that.
Yeah, we set that up yesterday before we got to say we
You can probably just push it to that table over there, because there's no one sitting over there. I think it'll be out of the way. Yeah, it'll be out of the way over there.
I was getting ready to say, I hope we don't have to do anything to all the electricity down.
Is this thing rewound and ready to go, James?
You do. No, you don't. You just use those hands, don't you?
Chinese do. I know about that, Very good.
This presentation describes recommended methods for placing asphalt hot mix. It is presented by the Asphalt Institute and the National Asphalt Pavement Association. The purpose of this presentation is to encourage practices which will produce good quality, smooth asphalt pavement. Placing the asphalt plant mix is the culmination of all the efforts and skills expended